Hello everyone, and welcome to this rather very short video in which we are going to talk about getting the nodal displacements and storing it in its corresponding nodes. So this is not going to be a crazy video, it's going to be a shorter video, and I think we deserve that because recently, like in the very recent past, not the previous video, but during the load videos, it was always like kind of a life and death situation in programming. But I think things are kind of cooling down, which is nice. So with that being said, we're going to talk about this. And as per usual, I want to remind you that this is part of two video series, one of them about the theory and the other one about the programming, linked to the top right, and that my dear channel members have access to the entire source code. But if you're not a channel member, then don't worry, because in the end, every single line I write here, you can write along with me and you would have the exact same code as me. So with that being said, without further ado, sit back, relax, and enjoy this rather short show. Okay, so the final thing is the get nodal displacements. Here I will declare degree of freedom to be 6, and I will just start looping things. So for I equals 0, 1, to the length of object.femNodes, so we are looping through the femNodes, and we're ending the loop here, which means this must become j, otherwise we risk, or something else. Otherwise, we would risk interchanging the index. So here we are looping through the femNodes, which means it makes sense that we should fish out the femNode. So femNode equals femNodes of I. We're fishing it out. And now we should go through the load cases. Maybe I should call it load case index, just to make a little bit more sense here. And yeah, for each load case index, I'm going to declare a vector. I think I should declare a vector. Let's first of all go to femNode and declare the deflections. So let me go to femNode very quickly, check if I added the deflections there. There they are. And to the str node, let me check if I added the deflections there. I did. Perfect. So now we need to declare them. We need to initialize them, okay? So here, I'm gonna init it. So for the femNode dot deflections, let's initialize it. So I think I said million videos before that I wanted here the degrees of freedom to be my columns, so here 6, and that the load case is gonna be my row. So this is gonna be length dot the number of load cases. Maybe I should get the number of load cases here to make it shorter. So number load cases equals this thing, which means I can use it here, and I can use it here, and I can consider this to be degree of freedom. So now we are initializing the femNode. Okay, so we initialized it. We're going to add stuff to it. So here, for each load case index, I'm going to cycle through the degrees of freedom. So for DOF index equals 1 all the way to DOF, we are going to do the following. We are going to get the deflection, which is from object.global displacement matrix, and we're going to take the degree of freedom. Oh, that's going to be an equation, right? Because I have a femNode. So here, the equation for that thing is going to be femNode dot ID minus 1, yeah, it's an equation, multiplied by the degrees of freedom, plus 1, no, plus DOF index, right? Because we're going to cycle through that. And the load case, right? And the load case is load case index. Yeah, so that's how we fish out the deflection. And now we store it. How do I store it? femNode dot deflections of. Okay, the row is the load case, right? So here, load case index, and the column is degree of freedom, so here DOF index. I'm pretty sure there will be bugs. There is a debugging session soon, but for now, let's just enjoy the serenity of coding without checking, which is something that will never happen. I made a mistake. Now this should equal to the deflection that I fished out. Okay, that's that, right? I think I finished. Yeah, I think I finished. Now, for the femNode, that's easy. I can go to, okay, now I need to check. So, if is object femnode.corresponding str node, just to make sure that there is something that exists. If there exists a corresponding str node, I need this, then set the deflection of that dude the same as the deflections I have, because I already fished it out. That's everything. Yeah, I think that is what I want to do. I still haven't debugged anything, but at least this algorithm's objective here is to fish out the correct displacements from the global displacement matrix and store it in every individual fem node and its corresponding str node if it exists. Because later, I will use the str nodes to draw, and the fem nodes, to draw the deflection shape. But that's something for another video. So, that's everything I wanted to talk about today. I still haven't debugged anything. I will have to do that later. But with that being said, I want to give a nodal displacement sized shout out to my dear channel members in the contributor level and the helper level whose names are going to be shown on the screen. I want to thank them from the bottom of my heart, as their support of the channel is priceless to me and enables me to provide you with videos hopefully on time and with a certain quality I try to achieve, and for that I am forever thankful. In the end, I hope that you enjoyed the video and you found it beneficial. If you have enjoyed the video, then please consider liking, sharing, subscribing, commenting, and so on, especially subscribing, because it helps increase the reach of my channel. As per usual, this is the Civil Engineering Essentials channel, and we'll catch you in the next video. Bye bye.